In this video, we're going to evaluate the integral of secant to the third and then use the derivative of the answer to check the result. And we're going to use integration by parts on this problem. So we're going to need a u and a dv to solve it. So we're going to break this up into secant squared and secant x dx. So I'm going to let the u equal the secant of x, and the dv will equal to secant squared of x dx. Those will be the two parts in this problem. I can take the derivative of secant of x, and secant squared of x has an integral. So my du will equal to the derivative of secant, which is secant x tangent x. This will be dx. And then for the second part here, dv equal to secant squared of x dx, we integrate both sides of this with respect to v, with respect to x over here, so I get a v here is equal to tangent. Integral of secant squared is tangent of x. And then over here then, integration by parts then is going to be the formula is integral of u dv is equal to the product u times v minus the integral of v du. So this is your standard formula for integration by parts. First part of the answer is the product of u and v. So u is secant x and v is tangent x. So this is going to be secant x tangent x. That's the first part of the answer. Now the second part here involves an integral, and the formula has a minus there, you can see it. And then it's the integral here v, and right here's v, that's tangent of x, and then the second part is du. So here's my du. So I got the secant of x tangent of x dx. And I'm going to go over here, I'll get more space here. So equals to, first part is still the same, that's secant of x tangent of x. And then it's minus, and then here I have tangent and tangent, so this will be the integral here of tangent squared of x, secant of x. Multiplying the tangent and the tangent, we get tangent squared here. Now I'm going to replace this tangent squared using the identity 1 plus tangent squared equals to secant squared. So this identity can be replaced by secant, or this term I should say, secant squared of x can be replaced by secant squared minus 1. Again, I'm using this identity 1 plus tangent squared of x is equal to secant squared of x. Solving for tangent squared here, I get secant squared, and this should be an x here. So replace the tangent squared of x by secant squared of x minus 1 using this identity over here. And then I'm going to multiply through by secant. This part is going to stay the same. And then this will be a minus. And then multiplying this expression here, secant squared of x minus 1 by secant of x. I'm going to write this as secant to the third of x, and then minus 1 times the secant of x gives me secant of x. We got this. And then I'll rewrite this now. Secant of x, tangent of x. I'm going to distribute the negative here. So we still got the equals here. Distribute the negative here and write this as two integrals over here. So this will give me a minus the integral of secant to the third of x. Then minus minus gives me a plus. This is dx here. This will be plus the integral of secant of x dx. And you see this integral right here is what we started off with at the very beginning. The integral of secant to the third. And that's what we're solving for. So what we're going to do then is bring this integral to the other side. So the integral of secant cubed of x will add to this first one. So it's two of those. So what I'll do, just to make it easier here, is do this. This becomes a 2 then. So what I'm doing here is I'm adding this integral here to both sides, plus the integral of secant cubed of x dx. So it cancels this one, and then I add it to the other side. So this gives me a 2 right there. So this then becomes secant of x, tangent of x, and I still have an integral on the right side. So this is secant, integral of secant of x dx. So from this step here, we go to this one over here. Like I said, adding the integral of secant cubed of x to both sides puts a 2 right over here. So this gives me then secant of x, tangent of x, and then we need the integral of secant of x. And this is the one that I did in another video. So I'm just going to give you the answer to this one. And if I find it, I'll go ahead and post it in the description. This will be plus, it's ln natural log of absolute secant of x plus tangent of x. All we need to do now is complete the solution here. So we have 2 integral of secant cubed of x, so we divide everything by 2. So divide by 2, this cancels out. Divide by 2 over here gives me a 1/2 right here. Divide this by 2 gives me a 1/2 right here. And then I got the constant of integration. So the integral of secant cubed of x is equal to 1/2 secant of x, tangent of x, plus 1/2 natural log of absolute value of secant of x plus tangent of x. That's your solution. Now to check. So get this, and now we simply have to take the derivative of this answer here, and we're supposed to get the original integral. Integral of secant cubed of x. So here's what we have. Here's the answer we just got. And of course we had the constant. And all I did is I factored the 1/2. I factored the 1/2 here. And we take the derivative of this. You can always factor the 1/2 here. And just take the derivative of this. What I do is say, well, the derivative of a constant is 0, so this one's gone. That's going to be gone. And I'm going to take the 1/2 out in front, put the 1/2 here, and then compute the derivative of what I have in there. And then whatever I get is just multiply by 1/2. Just one way to do it. So let's do this. The product here of secant and tangent, have to use the product rule here. So this will give me secant of x times the tangent, that's secant squared of x. So it's the first function times the derivative of the second, plus the second, which is tangent of x, times the derivative of secant. And that's going to be secant of x, tangent of x. So again, we're using the product rule to compute the derivative here. Secant times the derivative of tangent is secant squared. And then it's tangent times the derivative of secant. And that's secant tangent. You got this. So let's rewrite this here. Secant times secant squared. This is going to be secant cube of x. And then right above here then, got tangent times tangent, so that's tangent squared of x. Multiplying the tangent, still got the secant of x. And then on the natural log of secant x plus tangent of x, the root of that is whatever we have in the absolute values, that goes in the denominator. So this will be secant of x plus tangent of x. And then in the numerator, we put the derivative of secant of x plus tangent of x. So the derivative of secant is secant of x, tangent of x, and the derivative of tangent is secant squared. So let me just put this up here, plus secant squared. So let's factor out a secant here from the numerator. Taking out a secant, that still leaves me a secant there, and a tangent over here. So this will be secant plus tangent of x. So in the numerator, I have secant of x, and then the multiplied by secant of x plus tangent of x. But this and this will cancel. So all I'm left with is secant of x for this one, on this third expression over here. And then for this one here, tangent squared of x can be written as secant squared of x minus 1, and that's multiplied by secant of x. So we have 1/2, and we have secant cube of x. So just writing out what we have left. So now with this one here, if I multiply this out, secant times secant squared, that's secant squared here minus 1, gives me secant cube of x. And then secant of x times minus 1 is minus secant of x. And then I have this secant of x from the third expression here. So this is plus secant of x. So we got then combining terms, minus secant of x plus secant of x. Those cancel out. So I got 1/2. So 1/2 times secant cubed is 1/2. Well, let me add them up first. So I have a secant cubed of x and a plus secant cubed of x. This is 2 secant cube of x. 1/2 times 2 is 1, so I get secant. You get secant cube of x, which was the integral for the original integral. So there's your check. It's a little bit involved, but it's a good exercise to practice your derivative. Thanks for watching. We'll see you next time.